Vast Haven-1 launch in Q1 2024, investment in advanced propulsion systems. Date, January 29, 2025. Event summary. In the first quarter of 2024, Vast will launch its Haven-1 spacecraft, marking a pivotal moment in the space industry with a strategic investment of $15 million dedicated to advanced propulsion systems. This ambitious project is set to unfold in 4 distinct stages, each aimed at enhancing Vast's capabilities and positioning the company as a key player in the evolving aerospace market. Stage 1: Conceptual Design. The initial phase focuses on the conceptual design of the propulsion technology. During this stage, Vast's engineering teams will develop initial blueprints and specifications that will lay the foundation for future developments. This stage is crucial for determining the feasibility of the technology and ensuring it meets the rigorous standards required for space applications. The design process includes considerations of performance efficiency and potential applications in various space missions. Stage 2: Prototyping and Testing. Following the conceptual design, Stage 2 will involve prototyping and extensive testing of the propulsion systems. The prototypes will undergo rigorous trials to evaluate their performance metrics and safety standards. This testing will include both simulations and real-world applications to ensure that the technology can perform reliably under various conditions. The data collected during this stage will be vital for refining the propulsion systems and addressing any potential issues before full-scale production. Stage 3: Production. Once the prototypes are validated, Stage 3 will shift focus to production. This stage will involve scaling up the manufacturing processes to ensure that the propulsion technology can be produced efficiently and cost-effectively for mass deployment. Vast aims to optimize production techniques to maintain high quality while reducing costs, positioning itself to meet the growing demand for advanced propulsion systems in the space industry. Stage 4: Deployment and Operational Support. The final stage encompasses the deployment of the propulsion systems into the Haven-1 spacecraft, followed by operational support for initial missions. This phase will also include establishing feedback loops to refine the technology based on operational data. Vast's commitment to ongoing support emphasizes the importance of adaptability and continuous improvement in aerospace technology. Investment rationale. The $15 million investment in advanced propulsion technologies reflects a broader trend in the space industry toward enhancing efficiency and reducing operational costs. As the demand for innovative solutions in space exploration grows, Vast's investment is set to position the company as a leader in this competitive landscape. By focusing on advanced propulsion systems, Vast aims to improve the performance of its spacecraft while also meeting the increasing demands of commercial and governmental space missions. Market context. The emphasis on advanced propulsion systems is indicative of a significant shift within the aerospace industry, where innovation is paramount. As private companies increasingly participate in space exploration alongside governmental agencies, the need for reliable and efficient propulsion technologies has never been greater. Vast's structured approach to development, spanning conceptual design, prototyping, production, and deployment, mirrors industry best practices and underscores the company's commitment to excellence. Timeline of key events. Q1 2024, launch of Vast Haven-1 and initiation of the $15 million investment in advanced propulsion systems. Stage 1: Conceptual Design Phase. Establishing blueprints and specifications. Stage 2: Prototyping and extensive testing to validate technology and performance metrics. Stage 3: Scaling up production processes for mass deployment of propulsion systems. Stage 4: Integration into Haven-1 and support for operational missions, leveraging feedback for further refinement. Conclusion. The Vast Haven-1 launch in Q1 2024 represents a significant step forward in aerospace innovation. With a strategic investment in advanced propulsion systems and a structured development approach, Vast is well positioned to make a lasting impact in the space industry. The company's focus on efficiency and cost-effectiveness aligns with the growing demands of space exploration, setting the stage for future successes in upcoming missions. The launch of Vast Haven-1 in Q1 2024 marks a significant milestone in the realm of advanced propulsion systems, with a substantial investment of $15 million dedicated to its development. This project is structured into 4 strategic stages that encompass the entire lifecycle of the technology, from conception to operational deployment, aiming to enhance capabilities within the space industry. 1. Stage 1 – Conceptual Design. This initial phase is pivotal as it lays the foundation for the project. Here the team will focus on creating blueprints and specifications for the propulsion technology. This stage is crucial because it establishes the parameters within which the subsequent phases will operate. The design process will involve a blend of theoretical modeling and practical considerations, ensuring the technology is not only innovative but also viable for real-world applications. 2. Stage 2 – Prototyping and Testing. Following the design phase, the next step involves the creation of prototypes and their rigorous testing. This phase will evaluate the performance metrics and safety standards of the propulsion systems. Testing will not be limited to simulations, real-world applications will also be included to guarantee reliability under various operational conditions. The insights gained from this stage will be instrumental in refining the technology and identifying any necessary adjustments before mass production. 3. Stage 3 – Production. Upon successful validation of the prototypes, the project will transition into the production phase. This stage is centered around scaling up manufacturing processes to ensure that the technology can be produced efficiently and cost-effectively. This phase will also address logistics, supply chain management, and quality control processes to guarantee that the final product meets the required specifications and standards for operational deployment. 4. Stage 4 – Deployment and Operational Support. The final stage involves integrating the propulsion systems into the Haven-1 spacecraft, followed by providing operational support for initial missions. This phase is critical as it connects the development process with actual space operations. Feedback loops will be established to gather data from initial missions, allowing for continuous improvement and refinement of the technology based on operational experiences. Investing $15 million into advanced propulsion technologies indicates a strong belief in the market potential of innovative space solutions. This strategic move aligns with the broader trend within the space industry that prioritizes efficiency and cost reduction, ultimately aiming to position VAST as a formidable competitor in the rapidly evolving aerospace market. Counterintuitive information. 1. Investment in a softening market. It may seem counterintuitive to invest heavily in advanced propulsion systems when the overall aerospace market has fluctuated and faced challenges. However, this investment reflects a strategic foresight, the belief that technological advancements can carve out competitive advantages even in turbulent times. 2. Emphasis on prototyping. Typically, projects may rush to production based on theoretical designs. VAST's approach to emphasize thorough prototyping and real-world testing may contrast with conventional practices that prioritize speed over reliability. This could lead to more robust systems at the cost of time, but ultimately positions VAST better for long-term success. 3. Feedback loops as a strategy. In many industries, operational feedback is often seen as a reactive measure. VAST's proactive establishment of feedback loops from initial missions to refine technology suggests a forward-thinking approach that can rapidly adapt to real-world challenges, setting a new standard for responsiveness in aerospace development. For production scale-up prior to full testing, the sequence of moving to production after prototyping even before full-scale testing is complete may seem risky. However, it indicates a confidence in the technology's potential, suggesting that VAST may be leveraging iterative improvements to enhance production efficiency rather than waiting for a perfect product, which can often delay market entry. 5. Integration of advanced systems in initial missions. the integration of advanced propulsion systems into early missions might seem risky given the potential for unforeseen issues. Yet this could also be a strategic move to quickly identify and address any shortcomings in a real-world context, allowing for immediate improvements and adaptations in future missions. This structured and strategic approach positions VAST for a significant impact not only on its projects but also on the broader landscape of aerospace innovation, demonstrating that calculated risks and thorough preparation can yield substantial long-term benefits in a competitive and evolving industry. Key insights from the VAST Haven-1 launch report. 1. Investment in advanced propulsion systems. The report emphasizes the significant $15 million investment by VAST to develop advanced propulsion systems. This funding reflects a strategic pivot towards innovation in the space industry. While many may focus solely on the financial aspect, it is crucial to recognize that such investments are often indicators of long-term vision and sustainability in a rapidly evolving market. The significance lies in the potential to revolutionize space travel and exploration, making it more efficient and cost-effective. 2. For stages of implementation, the structured approach to the development process, comprising conceptual design, prototyping, production, and deployment, mirrors best practices in technology development. This framework is often overlooked but is essential for ensuring systematic progress and risk management throughout the project lifecycle. Each stage builds upon the previous one, and the emphasis on rigorous testing in Stage 2 is particularly important for validating the technology's reliability before mass production. 3. Operational support and feedback loops, the final stage of implementation, which includes deployment and operational support, is often underestimated. This phase not only involves the integration of propulsion systems into the Haven-1 spacecraft but also the establishment of feedback mechanisms. These loops are crucial for refining technology based on real-world data and can significantly impact future developments and operational efficiency. 4. Market positioning and competitive advantage. VAST's commitment to innovative propulsion technology positions it to potentially become a key player in the evolving space market. While many reports focus on immediate financial implications, the ability to innovate and adapt to market demands can provide a competitive edge that leads to long-term success. This strategic positioning can also attract further investment and partnerships, enhancing VAST's capabilities and market presence. 5. Technological advancements and cost reductions. The focus on increasing efficiency and reducing operational costs through advanced propulsion systems is a common theme in the space industry. However, the report highlights that the implications of these advancements extend beyond mere cost savings. Efficient propulsion can lead to longer missions, greater payload capacities, and broader exploration opportunities, fundamentally changing the landscape of space travel. 6. Feedback mechanisms for continuous improvement. The report's mention of feedback loops for technology refinement post-deployment is significant. This iterative approach to technology development can foster a culture of continuous improvement, ensuring that VAST can adapt and enhance its systems in response to operational challenges and user needs. Most reports may gloss over this aspect, but it is vital for maintaining technological relevance and operational excellence. 7. Broader trends in space exploration. The emphasis on advanced propulsion systems reflects a broader trend within the aerospace industry towards enhancing efficiency and sustainability. This shift is often overshadowed by discussions around specific missions or technologies. Yet it represents a fundamental change in how space missions are approached. The industry's collective movement towards more sustainable practices is significant, as it can lead to a paradigm shift in space exploration and potential regulation changes. 8. Investment in talent and expertise. While the financial investment is highlighted, the report does not explicitly discuss the potential implications for talent acquisition and retention. The development of advanced propulsion systems will require a skilled workforce, and VAST's investment could signal a commitment to attracting top talent in aerospace engineering and related fields. This aspect is crucial for fostering innovation and ensuring successful project execution. 9. Risk management through structured development. the structured approach to development not only aids in technology advancement but also serves as a risk management tool. By breaking down the process into distinct stages, VAST can identify potential pitfalls early, allocate resources effectively, and adapt its strategies to mitigate risks. This proactive stance is often overlooked in discussions around technology development but is essential for the success of complex projects. 10. Implications for future space missions. The successful implementation of advanced propulsion systems could have far-reaching implications for future space missions. The ability to enhance efficiency and reduce costs can open up new opportunities for exploration, commercial endeavors, and international collaborations. Understanding these implications is critical for stakeholders across the aerospace industry, from policymakers to private sector players. Conclusion. The VAST Haven-1 launch report contains several significant insights that many may overlook. From the strategic investment in advanced propulsion systems to the structured development approach and the emphasis on operational support, each element plays a vital role in shaping the future of space exploration. Recognizing the broader implications of these developments can help stakeholders understand the trajectory of the aerospace industry and the potential for innovation, collaboration, and growth in the coming years. 1. Investment in advanced propulsion systems. The $15 million investment in advanced propulsion systems signifies a bold step by VAST to enhance its capabilities in the space industry. This investment underscores the growing emphasis on innovative technologies that can optimize performance, increase efficiency, and reduce costs in space missions. As the space sector evolves, such strategic financial commitments are crucial for positioning companies like VAST as key players in a competitive market. 2. For stages of implementation. The structured approach to the development of the VAST Haven-1 project divided into 4 distinct stages: conceptual design, prototyping, and testing, production, and deployment, mirrors industry best practices. Each stage has specific objectives that build upon the previous phase, ensuring a comprehensive development process. This methodical progression not only enhances the reliability of the technology being developed but also facilitates risk management and resource allocation, which are vital in aerospace projects. 3. Market trends and demand for advanced technologies. The focus on advanced propulsion systems aligns with broader market trends in the aerospace industry, where there is an increasing demand for innovative solutions that can address the challenges of space exploration. As space missions become more complex and cost-sensitive, the industry is leaning towards technologies that can deliver higher performance at lower operational costs. VAST's initiative may position the company to capitalize on this demand, catering to both governmental and commercial space ventures. For integration of feedback loops for continuous improvement, the emphasis on operational support and the incorporation of feedback loops in the deployment stage is a critical point for ongoing innovation. By integrating real-world performance data back into the development cycle, VAST can refine its propulsion systems, ensuring they meet the evolving demands of future space missions. This iterative approach not only enhances the reliability and effectiveness of the technology but also fosters a culture of continuous improvement, which is essential for long-term success in the aerospace sector. These points provide a comprehensive overview of the strategic importance of the VAST Haven-1 launch, the structured implementation plan, market alignment, and the focus on continuous improvement through feedback mechanisms. 1. NASA's Apollo program, 1960s to 1970s. The Apollo program was a significant undertaking by NASA aimed at landing humans on the Moon and safely returning them to Earth. It involved multiple phases, including design, testing, and deployment of the Apollo spacecraft. The program saw the development of advanced propulsion systems, including the Saturn V rocket, which had to undergo rigorous testing and validation phases before it could carry astronauts. The program is a prime example of structured stages of implementation in aerospace engineering, with a total investment that amounted to over $25 billion in 1960s dollars, reflecting a similar commitment to technological advancement as seen in the VAST Haven-1 initiative. 2. The Space Shuttle Program, 1981 to 2011. NASA's Space Shuttle program was a revolutionary approach to space exploration, allowing for reusable spacecraft to transport astronauts and cargo to and from low Earth orbit. The program was broken into stages starting from design and development to operational missions and eventual retirement. The shuttle utilized advanced propulsion systems and included extensive prototyping and testing phases, much like the vast Haven-1 project. The program's total cost exceeded $196 billion over its lifespan, showcasing the substantial financial investment required for advanced space technologies. 3. The European Space Agency's Ariane 5 launch vehicle 1996 present. The Ariane 5 is a heavy-lift launch vehicle developed by the European Space Agency ESA and Arianespace. The development of Ariane 5 included a rigorous four-stage implementation process: initial design and conception, prototype creation, extensive testing including the infamous failure of the first launch in 1996, and operational deployment. Each stage was critically important for ensuring the rocket's reliability and success in launching satellites into orbit. The investment in Ariane 5's propulsion systems and overall technology development has been a key factor in establishing Europe as a strong player in the global space launch market, paralleling vast efforts to position itself in the evolving aerospace sector. Future outlook: Vast Haven-1 launch and advanced propulsion systems 2024 to 2034. The launch of Vast Haven-1 in Q1 2024, backed by a $15 million investment in advanced propulsion systems, marks a significant milestone in the aerospace sector. As this project unfolds across its 4 implementation stages, it sets the stage for transformative developments in space exploration and technology over the coming decade. 1. Stage 1, Conceptual Design 2024. In the initial phase, the focus will be on establishing the blueprints and specifications for the propulsion systems. This foundational work will involve collaboration among various stakeholders, including aerospace engineers, scientists, and industry experts. The conceptual design will emphasize sustainability, efficiency, and adaptability for future space missions. Future predictions: innovative design practices. The integration of AI and machine learning in design processes will enable rapid prototyping and optimization. Expect breakthroughs in propulsion technology that may lead to hybrid systems combining traditional and novel propulsion methods. Sustainability focus: as global awareness of climate change intensifies, designs will increasingly incorporate eco-friendly materials and energy-efficient systems, paving the way for greener missions. 2. Stage 2, Prototyping and Testing 2025 to 2026. This stage will encompass rigorous testing protocols to validate performance metrics and safety standards. Prototypes will undergo simulations and real-world trials, ensuring that the propulsion systems can withstand the rigors of space travel. Future predictions: enhanced testing techniques. The use of virtual reality (VR) and augmented reality (AR) during testing will allow engineers to simulate various scenarios, significantly reducing time and costs associated with physical trials. Collaboration with international space agencies. Expect partnerships with NASA, ESA, and other space agencies to leverage shared knowledge and resources, accelerating the testing phase and enhancing technology validation. 3. Stage 3, Production Scalability 2027 to 2028. Following successful testing, the focus will shift to scaling up production. This phase will prioritize efficient manufacturing processes to meet the growing demand for advanced propulsion systems in various aerospace applications. Future predictions: automation and robotics in manufacturing. The adoption of advanced robotics and automation will streamline production, reducing labor costs and increasing precision. This shift may lead to the establishment of more localized manufacturing facilities to minimize supply chain disruptions. Market expansion: as the demand for space exploration increases, particularly for commercial and tourism ventures, the propulsion systems developed for Haven-1 will likely find applications in satellite launches, interplanetary missions, and space tourism, thereby expanding market reach. 4. Stage 4, Deployment and Operational Support 2029 to 2034. The final stage involves the integration of these propulsion systems into the Haven-1 spacecraft and providing operational support for initial missions. Feedback loops will be established to refine technology based on real mission data. Future predictions. Data-driven improvements. Continuous data collection and analysis from missions will enable iterative improvements to propulsion systems, enhancing performance and reliability over time. Commercialization of space travel. As operational capabilities increase, expect a boom in commercial space travel and exploration, leading to new business models and opportunities in the space industry, including partnerships with private companies and governments. Broader implications for the space industry 2024 to 2034. 1. Economic growth. The advancements from the Haven-1 project are likely to stimulate economic growth within the aerospace sector, creating jobs and fostering technological innovation. 2. International collaboration. The project may catalyze further international collaboration in space exploration, reflecting a shift toward global partnerships and tackling shared challenges such as space debris and planetary defense. 3. Impact on other industries. Technologies developed for advanced propulsion may find applications in other sectors such as renewable energy, transportation, and telecommunications, leading to cross-industry innovation. 4. Regulatory frameworks. As commercial space ventures increase, regulatory frameworks will evolve to address safety, environmental concerns, and the ethical implications of space exploration. 5. Public interest and engagement. The successful launch and operation of Haven-1 could reignite public interest in space exploration, leading to increased support for funding and educational initiatives in STEM fields. Conclusion. The vast Haven-1 launch in Q1 2024 represents more than just a technological endeavor. It embodies a pivotal moment in the evolution of the aerospace industry. As the project progresses through its stages, it promises to reshape the future of space exploration, drive economic growth, and foster global collaboration. By 2034, the advancements made through Haven-1 could very well lay the groundwork for humanity's next great leap into the cosmos.